Okay, gel electrophoresis that you see here, didn't mean to do that. Um, this is the side view of what an agarose gel looks like. And you could see that on one side there's a negative electrode, and on the other side there's a positive electrode. And then you see the whole entire thing is filled with this buffer solution, and then inside is this gel. So think kind of like Jello, but not. Maybe more like the consistency of maybe a gummy bear, anywhere between Jello and a gummy bear. That's what I would describe it. And you can see this little indentation here, and these are the wells. So these are the little tiny indentations in which you're going to place your DNA that you've cut with restriction enzymes, and some type of dye has been added to it. Now, the question here is, which direction do you think the DNA is going to travel and why? So if you look at the top of this, it says DNA molecules are negatively charged. So they're going to travel through this gel towards the positive end. Let me click here. Okay. So I've got several pictures here and some videos for you to look at. The picture at the top and this picture, those are both a couple of screenshots from a couple of YouTube videos, not my videos, other videos on how to use an agarose gel. And then the second video, kind of like the green version, is watching the DNA move during gel electrophoresis, which is typically done in a dark room. I didn't post a picture of the dark room, but it's done in a dark room. The dye that's put in it is going to glow under UV light, but it's something that could take about an hour or so. The pictures over to the right, that kind of collage of pictures, this is from a class I took at UVA-Wise a few summers ago. And the one thing that I really enjoyed was getting to essentially do what they do for 23andMe, Ancestry.com, is to take a sample of our DNA from our spit and then go through this gel electrophoresis process to get a little piece of our DNA fingerprint that can then be used to compare. Now you can see everybody there is using these really teeny weeny little tiny droppers. They're called micropipettes, and you have to have a very steady hand to put your DNA with the added this ink, this stain, this dye into these wells, down into the well, so that it doesn't scatter about through your buffer solution. So this is what it looks like when you're finished. Now the picture over to the right is what our DNA looked like at UVA-Wise once it was finished going through. Now we weren't doing a lot, we were just doing a little bit. But this can be a small situation like the one you see that I got from UVA-Wise, or a very large where you're comparing DNA fragments from several different organisms and not just getting a particular person's that's going to be used against some type of database. So we have three different versions here, but the one that we're really going to focus on is the one in the middle. So what we have is this M is the DNA fingerprint from a particular piece of a gene, and it's been cut, so you don't use little tiny scissors or little tiny lasers to cut DNA. Instead, what you use are enzymes, and just like enzymes that cut your food, they're very specific. So M is the mama bear, the cub is the baby bear, and then 1, 2, and 3 are the potential papa bears. And how you work these out, or how you figure these out, is you look at the bands. Now the bands that are closer to the top, that's where the wells are, where you put in your DNA that has the stain in it. And the larger pieces don't move very far because they're large. They've got several base pairs, so there's a lot in there, and the smaller pieces move farther. So The way you figure out which of one of these is the potential dad is you're going to compare the dad's bands to the cub. And the more they have in common, that's your dad, or that's the Papa Bear. So if I look at Papa Bear number one, and I'm just looking at the cub, not mom, just the cub, I can see there's one, two, three, four. Four in common with the cub, four common bands. If I go to potential father number two, there's one, two, two. So he's out. And potential father number three, there's one. So father number one is the Papa Bear.